Welcome to Problems and Solutions. Today we'll solve problem 65 of chapter 10 of Fundamentals of Physics. A tall, cylindrical chimney falls over when its base is ruptured. Treat the chimney as a thin rod of length 55 meters. At the instant it makes an angle of 35 degrees with the vertical as it falls. What are A. the radial acceleration of the top, and B. the tangential acceleration of the top? Hint: use energy considerations, not a torque. C. At what angle theta is the tangential acceleration equal to g? Okay, here we have already some drawings of the situation we have. Here we have the position of the center of gravity, and here we have the angle theta as the chimney falls over. Let's use the energy conservation to solve the problem. In the initial situation, we have only potential energy, so we can write that potential energy will be mg and the height of the center of gravity, that is 8 divided by 2. This equals the potential energy in these situations, that is mg, 8 divided by 2, multiplied by the cosine of theta. We are projecting the position of the center of gravity considering the height of the center of gravity, plus the kinetic energy due to the rotational movement, that is 1/2 of the rotation inertia multiplied by the angular velocity squared, where the rotational inertia in this case can be written as 1/3 of the mass multiplied by the length squared. And now we can substitute this term in this equation. We'll copy this. Okay, so we'll have 1 divided by 6 and 8 squared omega squared. Now we can cancel the mass and also this 8 with this square. And we can multiply this equation by 2. So we have 8 equals g equals g cosine of theta plus 1/3 8 omega squared, and this implies that 8 omega squared equals 3g 1 minus cosine of theta. Now remember that the radial acceleration is r, the radius, multiplied by the angular velocity squared. In this case, we have the radius equals 8, so this term equals the radial acceleration. Therefore, the radial acceleration will be 3 multiplied by 9.81 multiplied by 1 minus cosine of 35 degrees. The radial acceleration equals, let's use our calculator, 3 times 9.81 times 1 minus cosine of 35 degrees. So 5.32 meters per second. This is the radial acceleration. So we solved item A. Now item B. Item B, we want to know the tangential acceleration of the top. Okay, let's start with this equation. This equation relates the angular velocity with an angle theta. If you take the derivative of both sides of this equation, we'll have in the left the derivative of the angular velocity, that is the angular acceleration. That's what we want. And will be related with the angle theta and maybe also with the angular velocity. Let's see. Let's take the derivative, the time derivative of both sides of the equation. So we have here this h, of course, is a constant. It's not necessary to consider. Let's not consider the constant. You have the time derivative of 1 minus cosine of theta. And let's use the chain rule to compute this derivative. That is, we take h is a constant, so we can take it off the sign of the derivative, and here we have the derivative with respect to omega of omega squared, and the derivative of omega with respect to time. This equals 3g, the derivative with respect to theta of 1 minus cosine of theta, and derivative of theta with respect to time. So we'll have h multiplied by 2 omega, and here the angular acceleration. This equals 3g, the derivative of 1 minus cosine of theta, that is sine of theta, and here we have the derivative of the angular position, that is angular velocity. So we can cancel the angular velocity, and you have h multiplied by alpha equals 3g. Oh, here we have 2. Oh, can take only, and we can divide here by 2. It's better. Sine of theta. Okay. Now remember that the tangential acceleration equals r times the angular acceleration. But in our case, the radius equals 8. So here we have the tangential acceleration. This equals 3 divided by 2, 9.81 sine of 35 degrees. Therefore, our tangential acceleration equals, let's see, 3 divided by 2 multiplied by 9.81 times sine of 35 degrees is equals 8.44 meters per second. This is the tangential acceleration. This is item B. C. At what angle theta is the tangential acceleration equal to g? Very simple. Here we have the tangential acceleration. This term is the tangential acceleration. So item C, we want that the tangential acceleration here equals to g. So we can cancel here, and we'll have sine of theta equals 2 divided by 3. Therefore, the angle equals, let's see, we want the inverse of the function sine of 2 divided by 3. Fourth one, 0.8 degrees here. And here we have the problem. The problem is solved.